Welcome back. Thank you for clicking on today's video. Today we're going to be doing our first example of a two-independent population t-test. So here we just want to see if there is in fact a difference in time to run a mile for GVSU track and field athletes, both past and present, wearing Nike shoes versus Saucony. So with this, I have measurements that pertain just to one group. So I have 54 track and field athletes wearing Nike shoes with an average time to run a mile of 4.45 seconds. And then 49 track and field wearing Saucony, and they have an average of 4.36. So I need to choose one to be group 1 and one to be group 2. So here, let's say that group 1 is the Nike shoe. Now, I choose that because they have a larger sample mean, so I'll be dealing with positive numbers. So we just want to see if there's a difference in their times. So that's going to affect how we write our null and alternative. And then the one thing that's not in here is the standard deviation, which for Saucony shoes was 34 seconds, and for Nike shoes it was 36 seconds. So now to start our Fred method, we have F and start with our two populations. So population 1 would be GV track and field athletes who wear Nikes. And then population 2 would be GV track and field athletes who wear Saucony. And then the samples, I'm not going to write out the whole thing, but this would be 54 and this would be 49. Again, I'm doing it from what we have up here. And then the variable is time to run a mile. And then my two parameters would be mu1. And always when you have mean or mu, you start with mean. So mean time to run a mile. Sorry about my penmanship. For GV athletes who wear Nike. And then mu2 would be mean time to run a mile for GV, and I really should be writing track and field, but I'm trying to save myself a little time, who wear Saucony. Okay, so when you write your null and alternative, then we have H sub O and H sub A, and we're going to use this notation. That's always the case. And so here we have mu1 equals mu2, and this is always your null. Sometimes you can change the direction if you have a one-tailed test, like a right-tailed or a left-tailed, but just for simplicity's sake, we'll have that always be the null. And here we just wanted to see if there was a difference, so our alternative is mu1 does not equal mu2. So that's the F. The R would be reviewing conditions. So here, reviewing conditions. Now, I already know one of my conditions is met because I would not expect the time for one group to affect the other group, so we can say that they are independent. And then you can see that they're fairly symmetric. There are a couple of outliers, but the sample size is large enough that I'm not worried about those, especially because they're not extreme. So we would say symmetric, check, outliers, check. And that would just be in the context of our sample size. So then for our E, executing calculations, we need to calculate the t-test statistic. And if you remember, that's x bar sub 1 minus x bar sub 2 all over s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. Now here, when I had group 1, my x bar sub 1 was 4 minutes and 45 seconds, so 4.75 would be that translation. And then x bar sub 2 would be about 4.52. So that is going to be plugged in here. So we have 4.75 minus 4.52. And then we said The sample size for this group was 54, and for this group was 49. Oops, sorry, I wasn't in frame. And then we had standard deviation being 36 seconds. So technically then, if we're going to put all of this in minute format, so 34 divided by 60, oops, that should have been 4.57. Like 45 divided by 60, that's where the 0.75 came from. 36 divided by 60, so this should actually be 0.6 because we're going to have it all in minute units. And then we had, what was it for the Saucony was 34. Oh, that's helpful. All right, there we go. And we're going to square that. And that, again, is coming from up here. These are all of the group 2 measurements for the Saucony. And then these are all of the group 1 measurements for Nike. So I'm trying to keep them all straight so that the measurements for group 1 stay with group 1 and similarly group 2 stay with group 2. So when I do this calculation, I have 4.75 minus 4.57, and I'm going to divide that by the square root of, and then in parentheses I have 0.6 squared divided by 54, and then I have 0.57 squared divided by 49, and close that, there we go. So I come up with a test statistic of 1.56. So then to find my p-value, remember you need three things. So you need your t, which here is 1.56. So that's going to put me on the curve here. You need your alternative, because this tells you how to highlight. And this is, remember, called a two-tailed test. So I'm also going to go down to negative 1.56. And then I am going to use conservative degrees of freedom, which is the last thing you need, and take 54 minus 1 and get 53. As it says in the textbook, the formula for degrees of freedom for this type of data is actually very complicated, so we're just going to make it easy on ourselves and do the conservative degrees of freedom. So I'm going to start by finding just this top tail. Remember, it wants a lower bound, so where the highlighting starts. So I have 1.56, and then remember that goes out to essentially positive infinity, so we have 999, and then I'm going to have 53 degrees of freedom. So this shaded area is equal to, let's just say 0.06. So then if I were to find this tail here, I'm going to do TCDF, and in the newer calculators it prompts you, in the older ones it's lower bound, upper bound degrees of freedom. So here our lower bound would technically be negative 999 to negative 0.56 to 53. And remember, if I did this correctly, these should match exactly, and you can see that that's true. So then to get your total p-value, you add those two up. So 0.12 is our p-value. So my p-value is equal to 0.12. So because that's fairly large, remember that that helps you to make the decision fail to reject the null, which means that when we do our D, so our drawing our conclusions, D, I would say there is insufficient evidence. Sorry, my handwriting today is worse than normal. Insufficient evidence to suggest, and then we're always going to restate our alternative. And so this is our alternative. So essentially, I'm going to take these two parameters, and in the middle, I would say differs from. So there's insufficient evidence to suggest the mean time to run a mile for GV athletes who wear Nikes differs from GV athletes who wear Sauconys. Now, technically, I could have said differs from the mean time to run a mile for, but this really, because I'm comparing the two groups and I already said what the mean was that we were comparing, this would be sufficient. And I mean sufficient in terms of my interpretation, not the amount of evidence. And then remember that if you have insufficient evidence, doing a confidence interval really is kind of a moot point because you already know that there's insufficient evidence to suggest a difference. So a confidence interval showing where the difference is or who has a larger average time wouldn't really make sense or tell you anything. So that's the first example. I will do another one in the next video. See you there.